Hi everybody and welcome. Today we're going to be going through a quick review of units 1, 2, and 3. We actually just had that last video as a unit 4 review. So actually after watching both of these videos, we'll be able to reflect on the semester of learning that we've done so far and hopefully just have a quick refresher for all those skills. This is getting us ready for next week. We're going to be looking at not high stakes, but just a quick, I'll say, review assessments of each of the 4 units. So we're going to basically next week be demonstrating our knowledge of each of units 1, 2, 3, and 4. So something to be ready for, and this video is going to help us kind of refresh our memory on quite a few of those skills. So with that being said, let's get started with unit 1, bringing us all the way back to the end of August actually. So our first skill that we did together, taking a look through here, was really thinking about the order of operations and simplifying and some expressions. So here we're given terms that we know, so like h is 6 and j is 4, so everywhere that we see an h and a j, we're going to replace it with those terms. So we have 6 plus h is 6 squared minus j, which is 4. I'm going to put those big parentheses around it, and all of that's going to be divided by 2. So this is the step where we have to remember the order of operations in PEMDAS, so a good application of that here, and it's going to be our job to go through and do that. So parentheses first. Specifically inside of these parentheses, we next see an exponent, so we're going to do 6 squared. So we'll have 6 plus 36 minus 4, all of that divided by 2. Again, still inside of the parentheses, we have addition and subtraction, so a little bit of choice here, looking at 42 minus 4. Again, still inside of our parentheses, all of that divided by 2. So we'll be left with 38 divided by 2, or a final answer of 19. So that's our job going through here. Again, plug in, follow PEMDAS, and you'll be in good shape. I left the next question, again, for you to practice plugging in, practice doing some of those order of operations, see how you do. Next, simplifying. Again, this is an example where you're not going to have a number as your final answer. You're still going to have some variables here. We're comfortable with that. We just want to take what they're giving us and simplify it, get it basically down to the smallest form possible. So still following PEMDAS, got to go all the way inside of the parentheses. These are not like terms, nothing we can do. So we're just going to distribute our 2 in here. So rewrite this as 4 minus 2, and then we have 6x minus 2 inside. So again, not like terms inside of our parentheses, all we can do is distribute. So one more round of distribution, we'll have 4 minus 12x plus 4. Last step here, we do have some like terms. So 4 and 4, so we'll end up with negative 12x and positive 8 as our final answer. And again, same idea for that next question. It looks scary with fractions, but actually if you multiply out, you'll have whole numbers for each of them. They multiply in there evenly. So same idea, do some distribution, combine some like terms, and get it to the simplest, least terms form possible. All right, moving on to our next one here, Unit 2. So Unit 2 had some solving equations for us, so a couple different ways. The first one here, we are comfortable with this at this point. We know that we are using inverse operations, so the opposite to move things from the left to the right side. And we're trying to get that x term alone by itself. 4 times x, the opposite is division. So we are left with here 15. For the next one, it's pretty similar. We're not solving this equation though. What they want us to do is just take this 8 and see if it works. So 7 plus 2 times 8. And let's see what that does. So that's 7 plus 16. That gets us 23. And they're asking us, does that equal 23? Well, yeah, it does. So we can say yes, it's a solution because it is balanced, both sides equal. If we had something like 23 equals 30, 23 does not equal 30, so that would not be true. It would be no, it's not a solution. Some extra practice on the bottom here, solving for a variable. So this is similar to like solving for y and y equals mx plus b, except it might not be solving for y, it might be something different. Here they basically want to get x alone. So set up your equation and move everything that's not x to the other side. And I should make my case a little bit neater here. So we're left with x over here, u plus k on the other side, and that's actually it. That's our final answer. X is alone, so we're happy. That's all that we needed to do there. So again, do the same thing here. Solve for x again. You need to move that c over to get x, again, by itself. All right, so continuing with our review here, moving on to some inequalities. A couple things to bring up. Again, important to make sure that we are remembering that we need to be careful with these signs. These are not equal signs. And a second thing to remember, I think we called it our star step here, is if you multiply or divide by a negative, you flip your inequality. So if it's this, it flips to this. If it's this, it flips to this. So whatever it is, basically make it the opposite if you multiply or divide by a negative. We don't have an example of that here, so we'll have 5x 15, divide both sides by 5, and we'll get x equals 3. Again, don't need to flip that sign and keep it exactly the same. We're not writing an equal sign here because, again, this is an inequality. So your job, do the same thing for that next question. Start moving that 3 over, start doing the division that you need to do, and you'll be in good shape there. All right, so that's it for Unit 2. So we went from expressions in Unit 1 to equations in Unit 2. Now for Unit 3, doing some of those extra skills that we were working on, like dimensional analysis, looking at perimeter, area, volume, all those types of things. So starting off first, dimensional analysis. We have 230 seconds, and our goal is to get this over to an answer that has minutes. Well, we have seconds on the top, so we need seconds on the bottom, and we're trying to get minutes on the top. So there are 60 seconds in 1 minute. If we do this, we're going to see seconds cancel, and we're just left with minutes, which is exactly what we want here. So we'll have to 230 over 60. That last step is we do need to do this division. We do need an answer here. So if we do 230 divided by 60, we'll end up with an answer of like 3.8. So we can say 3.8 minutes are in 230 seconds. And that seems reasonable to me. Again, 230 seconds. It's a bit more than 3 minutes, but still a bit less than 4 minutes. So yeah, it would fall in that range of about 3.8. So now a little bit of a longer question for you here on number 2. You have 180 days. And it's your job to go one step at a time, cancel out each unit until you get yourself to a place where you're all the way into minutes. So hours to minutes. And once you do this, you'll get the final answer in minutes. So again, days cancel, hours cancel, you're left with minutes, but you got to get these unit conversions. All right, so hopefully that helps for dimensional analysis. And we have a couple more skills to work on here. Our first one here is proportional figures. If we remember the example of the figurine, that little model that I was holding of the Empire State Building, it was proportional to the large one. So now it's our job to proportionally find the missing side length here. So we want to take our bottom and our long side, and we want to match it with, I'll put a B and an L for bottom and long side, with a bottom and long side from this one. Well, our bottom here is 4, and our long side is 11. So now that we have this proportion set up, we are able to do some cross multiplication. So 4x equals 11 times 52. And then now our last step here is let's divide both of these by 4 and get an answer for x. We should get an answer of x equals 143. And let's see if that's reasonable. So 11 is a little bit more than 2 times 4. And 143 is a little bit more than 2 times 52. So it seems like a reasonable side length there. So that checks out. So it's going to be your job to do the same thing for question 22. Again, set up a long side and a short side, just label something and make sure that they are matching in your proportion. All right, last question that we're going to do here on this slide before we finish up is Pythagorean theorem. So again, remember here that we have a squared plus b squared equals c squared. C squared is the long side. So we know that this is c, and then a and b are interchangeable. Doesn't matter which one goes where. And we're just solving an equation here. So we'll have 81, or I should do 9 squared plus 12 squared equals c squared. And in this case, evaluating that, so 81 plus 144 equals c squared. We can call that x squared here. Add those together. So 81 plus 144. It's going to give us that answer of 225. And then we take the root of both of these, and we'll get that answer that x equals 15. So x equals 15 here. So same setup for that second question. We have our A, we have our B, we have our C. Set up an equation, solve it, find that missing side length for Pythagorean theorem. All right, last skill to go through here, perimeter and area. So starting off with our first one here, let's do area first. We can break this out into a chunk. We know that this side length is 12. So this little square here has an area of 12 times 12. length times width. So area gets us 144. Next, for our triangle, triangles areas are 1/2 base times height. So we got here on the bottom 12, and then that height of 5. And when we go through this, we're going to see 12 times 5 gets us 60. Divide that by 2 for an area of 30. So that's going to be our top triangle here. So we got to take both of these chunks of area, so our 30 and our 144, add them together, and we'll get a final answer here of 174. Next, we have to do perimeter, which is a little bit more tricky because we got this triangle here. So if we take our edges, and I'll do this in a different color, we're just looking for not the inside, but we're looking for basically a tracing of the outside. So we have 5 here, 12 here, 12 on the bottom. We know that this is also 12 because it's a mirror of the other side, but what we don't know is that right there. So we have to take that triangle out, set it up, our little Pythagorean triangle. So a little bit of extra work here, x, 5, and 12. So 5 squared plus 12 squared equals x squared. So 25 plus 144 equals x squared, or 169 equals x squared. Square root both of those, x just equals 13. That's a Pythagorean triple, 5, 12, 13. So now that we have this, we know that that x now equals 13. So we can set up our perimeter. It's just adding up all the numbers we have on the edge. So 5, 12, 12, 12, and 13. When we do that, all the edges are accounted for, and we have our full perimeter. So we can just punch that into our calculator, add up all those pieces, and we will be in good shape there. So 5, 12, 12, 12, and 13 get us an area of 54. And again, let's use some units here. So meters squared for area, meters for perimeter. So a little bit more of an in-depth question, having to solve for both of those, especially because we had to break that triangle out and solve for the missing side. But we have all the skills. It's kind of combining a few skills that we've learned so far and putting it all together in one question. So we'll be able to do that, break those composite figures up into those shapes, and we'll be good to go. As always, everybody, questions, feel free to reach out, email, message, any of those things, book an appointment. We are here to support, and I will see you all in Teams very soon. Thanks so much.